Intro to Soil Health Part 5, Soil Function. In this video, we will talk about the characteristics of soils and how we can classify them, the important biological influences on soil, and what you can test for in your own soils. Characteristics of healthy agricultural soils include they are high in organic matter, their structure allows for soil pores that hold water and air, and they are not compacted. They contain living organisms essential for decomposition and nutrient cycling, nutrient availability, water holding capacity, they are well drained, they filter pollutants, they're hospitable in terms of pH for plants and soil organisms, they have diverse vegetation cover with living roots and sufficient depth. And of course, quality is dynamic based on soil management. Soils and natural systems have layers, while layers in agricultural soils may be less defined. The O layer, or the humus or organic matter, for example, decomposing leaves, is usually absent in conventionally managed agricultural soils. The A layer, or topsoil, is mostly minerals from parent material with incorporated organic matter. The B layer, or the subsoil, is rich in minerals leached down from the topsoil. The C layer, or the parent material, is geologic material from which soil horizons form. The R layer, or bedrock, is a mass of rock such as granite, basalt, quartzite, limestone, or sandstone that forms parent material. There are different ways we can determine the composition of soils. For example, by using the ribbon test, shown in the upper right, you can start by moistening a handful of soil and gently squeezing it between your fingers, creating a ribbon of dirt. If the soil is too gritty to hold its shape, it's sandy. If the ribbon breaks after reaching a length of 1 to 2 inches, your soil is loamy, or evenly proportioned with sand, silt, and clay. The sieves on the lower right have different size mesh, allowing us to physically separate sand, silt, and clay. From there, you can use the percentage of each component by weight, as well as the soil texture triangle on the left, to determine your soil type. Soil organic matter is the fraction of soil consisting of plant or animal tissue in various stages of decomposition. Most productive agricultural soils contain between 3 and 6% organic matter. Let's talk briefly about soil structure. As shown in the upper right, sand particles are larger than silt particles, which are larger than clay particles. On the left is an illustration of soil aggregates, which are groups of soil particles formed through physical, chemical, and biological activity below ground that bind to each other more strongly than to adjacent particles, creating pore space between aggregates. Bulk density, shown on the lower right, is an indicator of soil compaction. Soils with less compaction, or lower bulk density, will weigh less and have more pore space available for air, water, roots, and microorganisms. And we must remember that soil health depends on the living organisms in the soil, from bacteria, mycorrhizae, microarthropods, earthworms, and burrowing animals. They do the messy and magical work of breaking down waste and turning it into nutrients. The soil food web is the community of organisms living all or part of their lives in the soil. The yellow arrows indicate conversions of energy and nutrients as one organism eats another. The plant soil microbiome is the dynamic community of microorganisms associated with plants and soil. The rhizosphere is the region of the soil in the vicinity of plant roots in which the chemistry and microbiology is influenced by their growth, respiration, and nutrient exchange. In other words, the rhizosphere is the portion of soil most influenced by plants. You can have your own soils tested for many characteristics that affect the functionality of your soil. For example, soil quality, soil respiration, infiltration, bulk density, electrical conductivity or EC, which is the amount of salts in your soil, pH, nitrates, aggregate stability, the slake test, which measures soil stability, earthworms, structure, root patterns, topsoil depth, penetration resistance, soil texture, and water quality, for things like salinity and nitrate levels.